Hi, everybody. This is Dr. Dave with Physics 150 at Kalamazoo College, and I wanted to make a short little video to help those that were affected by our snow day. I hope that you're staying warm and staying dry. Um, the exercise that we're doing was how to turn graphs into words. And graphs are a particularly difficult spot for many students because when they see everyone talking about them, if you don't know what's going on, it's as if people are speaking a different language. So hopefully today's video is going to help dispel some of that for you. So the first thing we look at when we're looking at a graph is what is on this axis here. In this case, it's x, or position. And what is here? This is our time that we're looking at where our position is. Now, even though this thing might have like an arc to it, it doesn't mean that this is an up and down motion. It doesn't mean that someone threw a ball and it sailed through the air. This could be horizontal back and forth on a table. It could be up and down. We would need some kind of picture or some other guidance to help us understand what that is. Part of the exercise is you interpreting this in either a horizontal or vertical direction as you deem it to be appropriate. I realize it sounds a little bit open-ended, but that is part of the assignment. The other part is to read this plot and to make sense of what it says. So first things first, we've got our position variable, which we might call the y-axis. And it is telling us that this object starts somewhere, presumably in a negative position, and is moving towards the zero, our origin. So it's moving in a positive direction on its way through the origin until it reaches this location where it then turns back and comes into the negative direction. So let's try to make sense of what this means. Okay. So the first thing we can say using calculus, recalling that our velocity is the derivative of position with respect to time. That is, we can say that the slope here is positive. So we can say that the object is moving in a positive direction. However, when we look at the slope here versus the slope here, we can see the slope in the beginning is greater than the slope here. So therefore, we can say it is moving in the positive direction, but it is slowing down. And then at this location here, we can see the slope of the tangent line is 0. So it's moving in the positive direction, slowing down until it reaches this location in which it stops momentarily, and then it begins to go back in the opposite direction. So let's add a couple of labels here. Here we can say that the velocity is greater than 0. At this location, we can say the velocity equals 0. And then after this, we can see that it is now moving in the opposite direction back towards where the origin is. And its velocity at that location is less than 0. And then the object reaches this location. Now what happens here? Well, right now the slope is what? The slope is 0. So therefore, in this region, the velocity is 0. What does that mean? Well, it means the object stopped, right? The object stopped changing its location from whatever this time is to whatever that time is, and that's what that horizontal line is telling us. So now what happens? Well, now we're looking at the object and it's doing this. So here we can see the slope is positive, therefore the object's moving in the positive direction again. And we can see that the slope here and here and here are all the same, right? That's a straight line. So in this region, we can say that the velocity has some positive value. You can calculate the slope using your slope formula. But it is no longer speeding up or slowing down. It is simply moving at some constant rate. And that motion changes here as it begins to climb. And here you can see that its slope is increasing. So we can tell that the object is itself speeding up. So that's how we kind of understand what's happening with the position versus time plot and how the velocity plays into it. And if we look at it more closely, we see that there's actually 4 different regions that are occurring in this graph. There's this region here in which it is slowing down but moving in the positive direction until it stops and then goes this way, which is distinct from this region here, distinct from that region here, and distinct from that region here. So what do I mean by distinct? Here I'm talking about accelerations. So what we can see, if we recall that acceleration is the second derivative of position with respect to time, what we can see here is there are 4 different regions of concavity. And that is this region we say is concave down, this region has no concavity, this has no concavity, and this is concavity up or concave up. And I like to summarize this by what I call happy, sad cyclops. So that is, if your position versus time curve looks like this, that's what I call a happy cyclops, meaning your acceleration is positive. If your plot ever looks like this, that means your acceleration is negative, or what I call sad cyclops. And then if you ever look something like this, I guess it's just ho-hum zero cyclops. So let's go back now and look at this again. Here we can see sort of the frowning face of the position graph. So we can see that the acceleration is negative. Here we can see it's flat, so the acceleration is 0. Here we can see it's flat again, so the acceleration is 0. And here we can see it curving up, so the acceleration is positive. Okay, this should be a review from Calculus 1. If it's not, I do urge you to come into office hours and see one of us and get some help with that, or head over to the MPC. So let's look at a different plot. What if instead you had a velocity versus time plot? So now we don't necessarily know where we're located, but instead we know how our speed and our direction are changing. So what's happening at the beginning of this graph? Well, we see that our velocity is greater than 0, so we are moving in the positive direction. However, the value of our velocity is decreasing until our velocity reaches 0. So we're moving in the positive direction, but we're slowing down until we stop. And then what do? We reverse direction. Our velocity was positive. Now it's negative. So we've reversed direction. We're going the opposite direction until we reach, what is this? This is not stopping now because this is velocity. This is simply the largest negative value of our velocity until we turn back around and come up this way. But this entire time, our velocity was negative. So we were moving in the negative direction the entire time. We did not stop here because, again, this is velocity versus time instead of position versus time. Okay? So come back and take a look at this again. So we are always in motion in this graph, except for these two locations in which my velocity is 0. And then when I reach sort of, this region here, what do we see? We see that now the velocity is steadily increasing, and here the velocity is staying fixed. So what can we say about acceleration in this region? Well, velocity is the derivative, acceleration is the derivative of velocity with respect to time. So anytime this velocity curve is not constant, we are accelerating. So the only time that curve is constant is here. So in that region, the acceleration is 0. However, everywhere else, the acceleration is not 0. All right. So in this region, the acceleration is what? It's going to be positive because the slope is positive, and it's going to have some fixed value. However, in this region here, the acceleration is going to be changing always. And we'll talk about how to use one of these curves to generate another one of these curves in our next exercise, which is graphs to graphs. But this is roughly speaking what you need to understand the graphs to words exercise, with the only exception being how to understand what the acceleration versus time plot looks like. But I think if you've got velocity versus time and position versus time, you can understand that. If not, we encourage you to come to office hours. We encourage you to come to the MPC. We encourage you to be proactive with your learning in this class. Good luck. Stay warm. Thank you.